All right, let's try another example. Let's say that we have carbon monoxide reacting with water vapor, all gases, to produce carbon dioxide gas and hydrogen gas. And let's write the equilibrium expression. Let's say that we know that K is the concentration of CO2 times the concentration of H2 over the concentration of carbon monoxide times the concentration of water vapor. And let's say that we already know that this value is 5.1. So the question that something like this might ask is, calculate equilibrium concentrations if everything starts at 1 molar. So what we want to do is figure out which way this reaction is going to go. And the way we find that out is by calculating Q, the reaction quotient. So for this particular reaction, Q is equal to the initial concentrations of everything. And this one's pretty straightforward because we know that everything is 1 molar. So that means we plug everything in. That's 1, that's 1, that's 1, that's 1. Obviously, Q is 1. So what happens when Q is less than K? It has to shift towards the products. In other words, it has to make more product to increase the ratio of product to reactant. So we know that if this reaction is going to run this way, it means that everything on this side is going to decrease and everything on this side is going to increase. So since this one's really nice, everything is 1-to-1, that makes things a bit more straightforward. Let's set up this thing called an ICE table. Remember that an ICE table stands for initial change equilibrium. So in our ICE table, we're going to start off with initial concentrations of everything. So here is CO2, here is H2, here is carbon monoxide, and here is H2O. And everything that we started off with was 1. So that makes it pretty straightforward. Okay. What's the change? Which direction is everything going to go in? Well, we know that the products, that's these guys, are all going to increase, and the reactants, that's these guys, are all going to decrease. By how much? Well, everything is stoichiometrically equal to 1, so everything's going to change by the same amount. These are going to increase by x, and these are going to decrease by x. So when we're done at equilibrium, the reactants will be 1 plus x, and those will be the products. The products will be 1 plus x, and the reactants will be 1 minus x. So we can easily solve for this because we know K is equal to 5.1. And let's write the equilibrium expression. We already have that up there. So we're going to put our products on the top. They're all going to increase by x. We'll put our reactants on the bottom. And now I'm going to go through the laborious process of solving for x. So here's how we're going to do this one. Obviously, let's try to simplify things a little bit. This is equal to 1 plus x squared, and this is equal to 1 minus x squared. So if we take the square root of everything, now what we have is 2.26 equals 1 plus x over 1 minus x. So I'm going to do my best to solve for x, and so here's, whoops, what happened there? I believe, there we go. Okay, so we're going to solve for x. So what we should get is, we're going to divide both sides, my OneNote's doing weird stuff, by 1 minus x. So we have 2.26, I'm sorry, we're going to multiply both sides by 1 minus x. So now we have 1 minus x equals 1 plus x. And now I'm going to express this out. So we have 2.26 minus 2.26x equals 1 plus x. And so now we're going to get all this stuff together, and we'll add x to this other side, and we'll subtract 1. So what we get is 3, remember that's a 1 next to that x, so we have 3.26x equals 1.26. That means x equals 0.387. So if I'm going to plug all this stuff in, x is equal to 0.387. What's my change? Up here, our products are going to increase by 0.387. So our final concentration of our products will be 1.387 molar. And these are all going to decrease by the same amount. So this is going to be 0.613 and 0.613. And that's all you do. The tricky part is solving for x. All right. So take it for a spin, and I will hopefully see you guys on the next one. All right.